In this video, you will learn about experimental probability. So in a previous lesson, we learned about what we called theoretical probability. Now, what's the difference between theoretical and experimental probability? So a theoretical probability is what is expected to happen based on mathematics. And as we've discussed, it's calculated by dividing the number of favorable outcomes by the number of possible outcomes. And we see that right here. So the probability of an event is equal to the number of favorable divided by the number of possible outcomes. Now that's in contrast with experimental probability. With experimental probability, this is found by using data collected from an experiment or a survey. All right, and when you do this, you calculate the probability by dividing the number of observed occurrences by the total number of trials. And we see that here in this little formula. So the probability of an event is found by taking the number of observed occurrences divided by the total number of trials. So what would this look like with an actual example? All right, well, let's say that we took a six-sided die, or a singular for dice, and you roll it 50 times, and you have the following results. So the number 1 was rolled 9 times, the number 2 was rolled 7 times, the number 3 was rolled 10 times, 4 was rolled 10 times, 5 was rolled 8 times, and 6 was rolled 6 times. So the experimental probability of 1, 2, 3, 4, 5, and 6 would be found by doing the following. So the probability of rolling a 1 based off our experiment is we have nine things that happen. Okay, that's the number of outcomes that we observed. So we have 9 outcomes divided by the total number of trials. So we rolled 50 times, so the probability would be 9 over 50. And you can write that as a percent, which would be 18%. And you basically just do that by converting into something over 100, right? So 50 times 2 gives you 100 on the bottom, 9 times 2 gives you 18 on the top. So you have 18 over 100, which gives you the 18%. So for all of these here with the 50 results, or the 50 trials, what we do is we take the numerator, multiply by 2 to find the probability. So for the probability of rolling a 2, we had 7 times that the 2 was landed on, and there were 50 different trials total. So we take the 7 divided by 50, and that gives you 14%. 7 times 2 is 14. And then for the next one, probability of rolling a 3, we had 10 times that it landed on a 3, and there was 50 trials total. So we take the 10 divided by 50, that gives you 1 over 5, which is 20%. And then same thing for 4. The 4 was rolled 10 times as well. So we take 10 divided by 50 again, that gives you 20%. And then for the 5, we do 8 divided by 50, and that gives you 16%. And for the 6, that was landed on 6 times, so we take 6 divided by 50, which gives you 12%. So the experimental probability of rolling a 1, 2, 3, 4, 5, and 6 are listed out right here. Now, in contrast with the theoretical probability, which says that in theory, we can take the number of favorable outcomes and divide by the number of total possible outcomes. So for each of these, for 1, 2, 3, 4, 5, and 6, the number of favorable outcomes for each would be 1. So there's one thing you want to happen when you want to roll a 1, for example, and there's 6 things that could happen, right? It could land on any number, 1 through 6. So it's going to be 1 over 6 for the probability of landing on a 1. All right, and as a percent, you do 1 divided by 6, which would be 0.16 repeating. And as a percent, move it over 2 places. That gives you 16.66%, which can round to 16.7%. And then this would be the same thing for each of these numbers. There's an equal chance of landing on any one number. So the probability of landing on a 2, we still have one thing we want to happen, 6 things that could happen. Again, 1 divided by 6 would be 16.7%. That's going to be true for 3, 4, 5, and 6. That is your theoretical probability. That is what, in theory, based on the math, says we should be getting. All right, whereas in practice over here, when it actually happened, when you rolled 50 times, it didn't quite equal the numbers over here. But you'd find, though, that as you do more and more trials, so as you increase the number of times you roll the die to like 100 times, 1,000 times, 10,000 times, these numbers here from the experimental probability are going to be approaching more and more what we see over here in the theoretical probability. So with a relatively small number of experiments, these numbers will be probably somewhat close to the theoretical probability, but it's not going to be as close as if you were to roll, let's say, 10,000 times. All right, so in this lesson, we've learned the difference between experimental and theoretical probability, and we've learned how to find the experimental probability based off a particular trial. And that concludes our lesson for today. We will see you next time.